x what?
X and negative 2.
I'm sorry, I didn't hear.
X 2 minus 2.
Minus 2 and
X minus 3.
minus 3. Okay, so questions with the factor. You need to be able to do this. Not only do you need to be able to factor, when you see the practice test, which is about the length of the actual exam, you realize there is no time for you to, quote, figure out how to factor the day of the exam. Values of x that make the denominator, each of the factors here, 0, those are what we call our restricted values. X cannot equal some numbers. What number will make this expression 0?
2.
If I put a 2 in here, the denominator becomes 0. That means x is not allowed to be 2. And what value of x would make this factor 0?
3.
3.
So whatever's in the denominator?
Whatever makes the denominator 0 makes the expression undefined, right? Because we cannot divide by 0. We cannot. We can divide by 0. Now, once you've noted the restrictions, then you cross out the common factors and you write your final answer. Your final answer will be what? This expression here will always give you the same value as what expression?
X plus 5.
X plus 5.
X minus 3.
X minus 3. And then you repeat your restrictions. Notice that here you will still have the restriction of 3. But if you cancel it out the way many students do, and they look at this, they write the restriction, oh, x cannot equal 3. And they forget that this doesn't work for 2 either. And then we have it right here. So you must write x cannot equal 2 or 3. And that's what you would write. These are called the restrictions of x. And you only have one problem on the test in which I'm going to ask you to write restrictions. You must do the, because it doesn't matter when you do it. My only problem is that when students do that, and they get here, they'll never remember to go back and do the restrictions from the original problem. They'll just say, oh, the denominator will be 0 if x equals 3. Not realizing that the original denominator, this one, is also 0 when x equals 2. So before you cross that x minus 2 out, write down your restriction, and then you don't have it. 2x squared minus x minus 1 all over x squared plus 8x plus 15. Now this problem is not difficult on its own. It's not a hard problem. It is long. It's tedious. And for someone who hasn't practiced a bunch of these problems, it's going to be, I would just say skip it on the test, and if you have time, come back to it, because it's going to take you some time to do it. Why? Because how many polynomials do you need to factor to do this problem?
4.
4. You got 4 factoring. And if factoring is not something that you have developed a certain comfort with yet, well then this is not the first problem you want to tackle on the test. It's just going to eat up too much of your time, unless you can factor fairly quickly. Before you factor though, you should do whatever you do whenever you're dividing fractions. Any suggestions? I haven't told you what to do, but I'm letting you know what to do.
Cancel?
Not yet.
The reciprocal?
You must change this into a multiplication, and then you can start cross-canceling. That's right, once you factor. So before you do anything, change the division into a multiplication in the usual way. Your first fraction will stay the same. Dividing this fraction by this fraction is the same as multiplying this fraction by what?
The reciprocal?
The reciprocal of the divisor, this fraction. So I will do this. And once I have a multiplication, then I factor and I cross-cancel. Well, I can cancel anything from the top with anything from the bottom at this point. Okay. So let me give you a chance. Just
So then you cancel?
you can cancel after you factor. I really hope I won't get anybody in this class doing this. Oh, the 2 cancels with the 2. The x squared cancels with the x squared. The 15 and the 6. Nothing like that. You can't cancel like that when you have additions. There's no canceling at this point. You can only cancel once you've gone from addition, adding of terms, into multiplying factors. Then the whole fact, when you have multiplication, then that's when things can be canceled. So don't do this. This is something that is not allowed. It brings a great deal of unhappiness. And I'm great. I don't want to see this cancellation.
will it give you like complete opposite?
Yeah, you're gonna give you the wrong answer, and not only that, you are very likely to get one of these on the exam. If I'm grading
no.
it. That's right, I won't hold back.
No tears?
Maybe.
So tears. Oh my gosh. That's dramatic.
Or maybe, depends on how I'm feeling, maybe it's.
Oh, no. What's worse?
I don't know. It all depends on how I'm feeling at the time. But don't test me. Don't go there. Don't cross cancel here until after you factor. So I'm waiting for answers now. I'm not factoring for you. You got one?
No, I mean, I just thinking, you can't cross cancel while they're in that form, right?
Right. And the reason is very simple. It's not like another one of a million rules that you have to quote memorize. You need to understand the nature of this cross canceling. Look, all of you understand numbers pretty well. If I gave you something like this, 3 plus 2 divided by 1 plus 3. 3 plus 2 is 5. 1 plus 3 is 4. The answer is 5/4, right? Now, if you are wondering, I wonder if I can factor here, and you do, you say, okay, I cancel the 3's. What's left? Well, it depends on how you look at this. Some students would look at a 1 right here and say 1 plus 2 is 3, and 1 plus 1 is 2. They might get, if they do that, they would get 3 over 2. Is that the same answer as this one? No. This is the right answer. We know that. And this is not the same. Now, why is it we cannot cross cancel here? Because the operations at play here, when you have an addition, and this is a division. Adding a 3 is not canceled by dividing by the addition of 3. In other words, these operations here are not opposites of each other. If I have this, 3 times 2 divided by 1 times 3, can I cancel in this instance?
Yes.
Here is perfectly okay. And that is because multiplication and division are opposite operations. So if I want to multiply a number by 3, and then turn around and divide by 3, I might as well do nothing, right? It's like the kind of questions that I would give you in the no calculator portion of the test. Like, what is 13 times 459 divided by 13? Well, you feel free to multiply if you want and get a huge number, and then you have a huge number to divide by 13. But what's the answer going to be? 459, right? Could you cancel if I told you this? No. And for that reason, you're not allowed to look at these terms individually and cancel, because you're adding it here. You're adding terms. When you write it in this way, in factor form, it's like you have this situation here, in which multiplication allows you to cancel, because multiplication and division undo each other. That's what I want you to understand. Not a rule, but it's just something that should make sense to you. All right, I'm still waiting for factored polynomials here. Did anyone factor this first one?
No, don't.
What is it?
X plus
2x plus 1 times 2x squared. That'll give me 6x, and 1x is 7x, and 3. Perfect. That works. So you do that with your box if you want to, or guessing check, any technique. But that's what you need to know how to do. How do you change from this form, standard form, into factored form? That takes a little practice, and you need to commit to that. Yes, sir.
Not to confuse anybody, but if we ever have like a polynomial on the top that has, let's say for example, addition on the top, on the numerator, and subtraction polynomial on the denominator.
Will they cancel?
Yeah, because they're opposites?
No, the answer is no, because of this line right here. When you say top and bottom, there's this line, and this line always means one operation. What does it mean?
Division.
Division. Division will always be there. And addition and subtraction never cancel through division. The only thing that will cancel through division is multiplication.
Okay.
And because that line will be in every fraction, you can only cancel when you have factors.
Okay.
That's a good point. So if you have something like 2 minus 8 divided by 6 plus 8, you cannot say, oh look, we're subtracting 8 and adding 8.
Right.
Yes, we are, but we're doing this, which is
The division.
dividing, and therefore we cannot cancel.
Okay.
These guys don't cancel over division, only multiplication. Good question. Good question. Does anyone have any of the other factored polynomials? Yes. Which one?
The bottom one.
Of this one? Okay. What do you have?
I have x plus 3,
Okay.
x plus 3.
Very nice. I agree. That's good. Yes.
The top one.
You have this one right here. What do you have?
X plus 3,
X plus 3.
x plus 5.
I agree with that one as well. And we're just waiting for the bottom one of the second fraction. Have, I heard x minus 1. Uh-huh. Okay.
Plus 1.
2x plus 1. Okay, let's double check that one. That'll give me 2x squared. Here we have 1x minus 2x is minus x, and negative 1. Perfect. Now that will take you a little while on the test. Right now we have the benefit that we have a classroom full of students, and you did different ones, so we got this pretty quickly, but this is time consuming. You know, and this will depend on your ability to factor. So now, once you factored, if you factor correctly, this is the point that I got a professor at Castle Fullerton, Dr. Gannon, that would always get to a point in a problem that he thought was very easy from that point, and this is what he called the child of 5 step. This is what you can hand over the pencil to a 5-year-old and let them finish. You just tell them, cross anything that you see on the top that matches the bottom. That's the easy part. Anything from the top will cancel anything with the bottom. Doesn't have to be a cross, anything from the top with the bottom. Anything? Let's see, 2x plus 1, can we cancel that?
Yes.
There's a 2x plus 1 right here. This is our child of 5. X plus 3. I have an x plus 3 right here. I can cancel that. Or this one, doesn't matter. How about this x plus 3?
Yes.
Yeah, there's one right here. Gone. How about this x plus 5?
No.
Nothing. And I've gone through everything. So this expression is equal to x plus 5 over. Now I want to emphasize that for these types of problems, I will not ask you to write restrictions. There's just too many. And you would have to worry about the original before you flip it over. There were restrictions here, and when you flip it over, now there's restrictions here. So it's not important. We just make the assumption that these two equations, these two expressions, this one here, and this one are equal as long as the denominators are not 0. So no restrictions required. You just write that down, and that's the way you're going to do this on the test. The factoring you can do on the side of scratch paper. At this point, I'm going to have a section on the test where I'm going to ask you to factor stuff. That I want to see step by step what you did. When you get to this part, you can do your factoring on the side so that you can keep this nice and neat. You don't want to put boxes here and X games and then get all confused. You want to keep this in order so you can see what you're doing. This is here, this one's here, and then everything works very nicely.